It's my pleasure to present you my presentation, which is about trends in nutrient management of fruit production systems. First of all, I would like to thank the organizers for inviting me. I'm a professor from Wageningen University and dealing with nutrient cycling and nutrient management and agroecosystems in different production systems in different parts of the world. I must say I'm not the expert in fruit production systems, but I have had some PhD students dealing with nutrient management in fruit production systems. So my topic, my outline of the presentation is that I first have some slides to explain what I mean by nutrient management. Then I will discuss some trends in global fruit production and nutrient management. Thereafter, I will present some results of recent meta-analysis studies and farm surveys. And finally, I have a summary and outlook of my presentation. At the right bottom of the screen, I want to emphasize that nutrient management is an important topic, also in relation to the Sustainable Development Goals. At least half of the total number of 17 Sustainable Development Goals have a link with nutrient management. So what is nutrient management? Nutrient management is a process of allocating and handling nutrient resources to achieve agronomic and environmental objectives. It consists of a series of 8 specific activities. It starts with analysis, then decision-making, planning, execution, monitoring, and control. And all these specific activities are focused on achieving objectives. Nutrient management makes use of a number of tools. In the first hand, it makes use of analysis of soil, leaves, nutrient balances, nutrient losses, and simulation models to see what kind of options there are. Based on these analyses, decisions have to be made related to what we call the 4R stewardship, which deals with the nutrient sources, the application modes and application places of the nutrient sources, and the application timing. Then, of course, it has to be implemented, and the results of nutrient management have to be monitored. And finally, there has to be control whether the objectives have been achieved or not. And that can be done on the basis of the analysis in the next season. So nutrient management is very much at the interface of science, practice, and policy. Basically, the term nutrient management was introduced in the 1980s when the first nutrient management governmental policies appeared. So when policy started to interfere with nutrient use in practice. So now nutrient management is very much at the interface of science, practice, and policy. If you talk with other people on nutrient management, it is clear that it is not pure science. It's the views on nutrient management are very much contextual. There are different ways of thinking, and they are related to differences in the objectives that people have in mind, economic versus environmental or societal, on views, what is useful and what is necessary. And it's also related to the progress that has been made already and that can be made by further actions. On the other hand, there is also consensus in general about that nutrient management is not easy. It requires in-depth knowledge of nutrient cycling and nutrient losses. There's also consensus that there is low-hanging fruit to improve nutrient management. But other actions might be painful, and that is what we have to consider as well. So if we talk about the general characteristics of global nutrient management of orchards, the first thing that comes in mind that is there is a huge diversity in fruit types and varieties. And at the same time, there is a huge diversity in climate, orchards, and practices. And the main division here I would like to make is a division between traditional practices and the professional practices in the professional orchards. Another important aspect is that there are often multi-nutritional constraints on yield and quality of nutrients. There is an increasing influence of processing industries and retail. They demand high quality products. And as I said before, there is an increasing influence of governmental regulations with demand that nutrients are used efficiently, and that relates also to, let's say, pesticides. A side effect of the increasing influence of different actors is that there is more privatization and thereby a limited exchange of information. And in general, I would like to emphasize that nutrient management of orchard is an under-researched topic. There is not much governmental support for research on nutrient management in orchards. So it has to come mainly from the private sector. In my presentation, I use a number of sources which come from experimental studies, so carefully carried out experiments in the field, simulation studies, and meta-analysis, which are based on experimental studies. I used also statistical data, census data, monitoring data, farm surveys, especially from China, where I have a number of PhD students. And of course, I used also expert data and interpretations. So if we talk about the global mean fruit production and consumption, it is striking that both the consumption in the right bottom panel is increasing. So the fruit consumption in kilocalorie per capita per year is steadily increasing. And as a consequence, the fruit production has to increase as well. But there are different crops that increase at a different level. Currently, banana is the main crop. It has surpassed apple production and orange production. And I also would like to emphasize that compared to, for example, cereal production or other crops, it is a cash crop. Fruit is a cash crop, and therefore there is relatively high input. Another important aspect of fruit production is in relation to nutrient management, is that is what presented here. The yields per hectare have increased during the last 60, 70 years, but that the area of fruit crop production has increased even harder, which means that there are new players coming into practice. As the harvested area is increasing, it is very likely that there are newcomers in fruit production, which may not have so much experience yet. This is, of course, the big picture is an average picture. The picture on the right-hand side shows that there are still huge differences between countries in, for example, yield per hectare. The right picture shows orange production, and there is a threefold difference in mean crop yield between, for example, USA and China. China is popping up. It is now the biggest producer of fruit in the world. It produces about 1/3 of global fruit, and the production is very rapidly increasing, as is shown by this picture. And as a consequence, the rest of the world, countries in the rest of the world, the top of the bars shown in the figures, are decreasing, have a relative decreasing contribution to the total fruit production. This has a number of implications also for nutrient management. In Europe, the picture is rather different. The areas of orchards and vineyards are relatively stable during the last couple of decades. Orchards and vineyards cover in total 4% of the agricultural land in the EU, but there are 40% of all farms in Europe that have an orchard or have a vineyard, meaning that the area of the orchards and vineyards are relatively small, and quite often they do it part-time. So only 1/3 is specialized in fruit or wine cultivation. 4% of the fruit growers have organic orchards. And there is an increasing focus on product quality and increasing influence also from governmental regulations on nutrient management. This is also an important indicator for global fruit production, that the export orientation ratio is relatively low, but increasing. The export orientation ratio indicates the export in percent of the total production. It's around 20% now. It's much lower than, for example, soybean, but it's much higher than, for example, fruits. And the more fruit is exported, the greater the influence of the processing industry and the trade companies, which demand high quality products. And that has, of course, also an influence on nutrient management. Yeah, in the world, in terms of exporters, Spain is the biggest exporter, and US and China are the biggest importer of fruits. But there is also a lot of exchange. So US and China are also exporters of fruit, but of different types of fruits. Now I come to some data about the nutrient use and nutrient management in China based on meta-analysis studies. So these meta-analysis studies, they summarize a large number of experimental studies from scientific papers. In this case, this meta-analysis study summarized results of 293 scientific papers, most of them from Chinese language. And there are a number of important points that I would like to emphasize. The left panel shows the response to nitrogen, phosphorus, and potassium application. And that is shown by box plots. The box plots indicate the 25 and 75 percentile values, and the solid line indicates the median value. Important here, what I would like to mention is the huge yield response. So on average, nitrogen increased yield by about 7 tons per hectare. Phosphorus increased yield by about 6 tons per hectare, and potassium increased yield also about 5 or 6 tons per hectare. The graph on the right hand side shows the optimum nitrogen, phosphorus, and potassium application rates. And that is again interesting. It shows that the optimum nitrogen fertilization rate is about 300 kilograms. For phosphorus, it's about 200, and for potassium, it's about 300. These are enormous quantities. Probably it is related to the fact that many of these experiments have been conducted in relatively young plantings, where the soil has still a low soil fertility. And that is also mentioned in the paper of Lee, that the yield responses were higher before 2000 than after 2000. So in the course of time, soil fertility has decreased and the responses to nutrients are decreasing. That is also the case for the partial factor productivity. I would like to emphasize that fruit quality was not examined at all, and also the, let's say, the longevity of the orchards was not taken into consideration. This is also important to show. This is the agronomic efficiency of nitrogen, phosphorus, and potassium application. The red line shows that the efficiency rapidly decreases with an increase in N application rates. So when the application rates decreases, the response decreases and the losses of nutrients also decrease, or the accumulation in the case of phosphorus increase as well. And here it also shows, this graph shows that the application rates ranges widely from 0 to up to more than 1,000 kilogram of nutrient per hectare per year. This is another meta-analysis study. This study summarizes results of orange production, global orange production, and emphasizes the need to both emphasize water and nitrogen inputs in orange production. If the water supply is relatively low, nitrogen has less effect on enhancing yield, and vice versa. So if nitrogen input is too low, irrigation doesn't have so much impact. And that it is also important to emphasize that nitrogen and water, they have also interactions in the nitrogen use efficiency and in the water use efficiency. So the water use efficiency is much higher if there is sufficient nitrogen, and vice versa. There is also negative interactions on nitrogen use efficiency in the right-hand corner. So these aspects, these results emphasize that it's important to consider the nutrients and water in coherence. Further studies have been done by this former PhD student on simulating water and nitrogen applications using simulation, a combination of different simulation models. And the important aspect is that these kind of simulation models provide rapidly and easily to interpret results and help the growers to find the best way to partitioning the split application. So how much nutrients should be given in the beginning of the growing season, in the mid part of the growing seasons, or at the end of the growing season. And this has different influences on yield, as showing in this column, nitrogen leaching, denitrification, and total nitrogen losses. The circle, the red circle, indicates the options which is best. So in total, we examined 10 different options with one uniform N application rate, which was more or less the optimum for the climatic conditions considered here. And you see that the ranks differ greatly depending on whether we focus on yield, leaching, denitrification. This kind of studies are very useful to examine quickly the best options that growers can consider in practice, or that experimental scientists should consider when they set up field experiments. Now we come to results of some farm surveys conducted again in China in 2018. In this group of students visited in total 1,400 farms, both cereal farms, vegetable farms, and fruit growers. And this table provides some overviews of the different farms that have been visited. So it's important to emphasize that all farms were relatively small. The average acreage of the farm was just 1 hectare. For fruit, it was the lowest, 0.8. On average, there were 2 people working on these farms, and the annual income in yuan was highest for vegetables, second for fruits, and third for cereals. But if we look to the percentage of income coming from cropping, the fruit orchard provided the highest income from farming. The last line shows the average age of the farmers. So, and the average age is rather high. The fruit growers, the average age was 57, but quite often farmers were 70 years or more of that. And that has, of course, implications for the eagerness to learn new technologies and to adapt new practices. These are some, for us at least, very surprising results. The panels on the left graph shows the nitrogen, phosphorus, and potassium application rates for those farmers that did not use animal manure. So on average, these farmers used 600 kilograms of nitrogen. It's shown by the blue box plots. They used on average slightly more than 200 kilograms of phosphorus and also more than 200 kilograms of potassium. The right-hand side figures shows those farmers that did not use manure. So that did use manure. So in total, 200 out of the 263 farmers, they used also animal manure as base fertilization. And on top of that, they used synthetic fertilizers. But again, huge amounts. For nitrogen, it was 400 to 500 kilograms, phosphorus 200, and potassium also 200. So these manure users used less synthetic fertilizer than farmers that did not use manure, but still the inputs were high. And these results, we checked it again with also other studies. In 2008, there were also studies conducted by Professor Zhang-Fu Suo, and they found at that time also very high inputs of nitrogen, phosphorus, and potassium in fruit production. The amounts of animal manure applied ranges between 150, let's say 100 to 200 kilograms of nitrogen, phosphorus, and potassium. It's shown at the bottom, right bottom panel. The students also asked about the farmers' knowledge about a number of aspects, and also about whether they are willing to use more and replace synthetic fertilizers by animal manure. And the graph on the right-hand side shows that the interviews were divided in what we call manure users and non-manure users. And here we show the results for cereals, vegetable, and orchard farmers. What we see is that there are big differences between the manure users and the non-manure users in the willingness to accept manure and to replace synthetic fertilizers by these manures. But the main barriers were lack of knowledge and lack of information about the availability and the quality of the manure. So many farmers were hesitant, and there is also a lack of proper manure application machinery. So the farmers find it labor intensive. If we now move to nutrient management in the professional orchards in the EU, the situation is completely different. Most of the professional orchards, they have private consultants that help them to set up a good nutrient management, a good fertilization schedule. And these consultants also advise the growers with pruning, pesticide application, and so on. All these growers, they use regular soil and leaf analysis. And they use a really intensive and targeted applications of nitrogen and other nutrients. Quite often these foliar applications are applied a number of times during the cropping season, depending on the growing stage. But in all cases, it is in relatively small quantities. So if you look to the application rates, it is a huge contrast with the situation in China. On average, the nitrogen application rates are somewhere between 25 and 100 kilograms, depending on the type of the crop. So lower rates are for the grapes, and the higher rates are for the pear application. For phosphorus, it's not more than 10 or 25 kilograms, and potassium is in the range of 50 to 100 kilograms. There is also a lot of real-time monitoring and observations. So to change the management on the go. And still, many growers argue that they have difficulties with meeting the environmental regulations related to, for example, the nitrates directive. Many farmers are also talking about the new policies that come on the table. So there is a trend towards climate smart and circular economy policies in the European Union. And they demand for new cultivars and new practices with less inputs. There is also a pressure to phase out synthetic fertilizers and to utilize recycled nutrients from manure and wastes. But that goes together with an increased risk of an unbalanced NPK fertilization with implications for fruit quality. So the growers have fear for that. And there's also pressure to save on irrigation water. And so the increased cost by more drip irrigation, fertigation. And there is also an increasing emphasis on soil carbon sequestration with implications for pruning and mulching. So there is quite a bit going on, emphasized also by the news related to, for example, the farm to fork policy of the European Commission. So now I slowly go to my summary of my messages. If we look to the global challenges of nutrient management during the next decades, I think there are two big challenges. That nutrient management has to contribute to increasing global food production by 50 to 100%. And at the same time, the global nitrogen and phosphorus use efficiency have to increase by 50 to 100% and decrease, and the losses have to decrease by 50 to 70% simultaneously, which is a huge task. I would also like to show this picture. This deals with the healthy diets from sustainable food system. It's a report presented by the EAT Lancet Commission. They have two targets for the future. Healthy diets, including fruits, and these diets should be produced by sustainable food production systems. And there are 7 key ecosystem processes that have to be considered. And 2 of them are nitrogen cycling and phosphorus cycling. but also biodiversity loss is very much related to the nitrogen and phosphorus, and also the freshwater. In my view, these targets, both the targets for healthy diets, target for sustainable food production system, they set the future for nutrient management as well. My personal view on nutrient management, in my view, the urgency and the complexity of nutrient management are large enough to give it a much higher priority in science, policy, and practice than currently. And that all actors in the food chain and in the fruit chain should be involved in nutrient management. And that mechanisms have to be found to compensate farmers for economic losses that go beyond best managed practices. I also would like to emphasize that nutrient management requires in-depth understanding of the nutrient cycling and transformation processes, and it requires high-quality data. So this sets targets for education, both for the growers and for researchers. And I think there's also more investment needed in understanding the social and psychological factors in nutrient management. Now I come to my summary and outlook. First, I would like to emphasize that there's a huge diversity in production systems with many smallholders. And professional production systems will become more dominant over time. So they will replace the traditional production systems. I would also like to emphasize that nutrient management is a process of specific activities, and it is aimed at achieving objectives. And the main tools are soil and leaf analysis, nutrient budgeting, simulation models, and specific application technology. It is the interface between science, practice, and policy that matters. But there are worries about contribution from science. And healthy food from sustainable food chain is a future guide for nutrient management. There are so much challenges related to achieving healthy food and sustainable food system. But also a climate smart and circular economy provide new challenges for nutrient management. So now I come to the end of my presentation. I would like to thank you for your attention. And I'm happy to answer any questions that you might have. Thank you.